Welcome to the Math Show Skill Drills with Mr. DeClerico. Everyone loves to receive a gift, and today we're going to talk about two mathematical gifts: the difference of squares and the perfect square trinomial, both of which make factoring a lot easier. Here's the difference of squares factorization. A squared minus b squared equals a plus b times a minus b. For example, 25x squared minus 16 factors to 5x plus 4 times 5x minus 4. Think about it. My first term is 25x squared. That's my a squared. Square rooting that would get me my value for a, which is 5x. 16 is b squared. Therefore, my value for b would be 4. Then it's just substitution. A plus b is 5x plus 4. The square root of my first term and the square root of my second term. The second factor, a minus b, is exactly the same, except it's a minus sign rather than a plus. But you may be wondering, like Mr. Penguin, why does this work? Well, just like in my last video, I'm going to start with the factorization, a plus b times a minus b. If I were to FOIL that, I would get a squared minus ab plus ab minus b squared. You'll notice those ab's are going to cancel, which leaves me with a squared minus b squared. I'm sure Mr. Penguin's satisfied after that explanation. Now let's try another one. Feel free to pause the video and see if you can factor this binomial. Okay, I'll assume we're ready to continue. The correct factorization is 3 plus 8x times 3 minus 8x. Since my first term is 9, a would be 3. Since my second term is 64x squared, b, the square root of that, would be 8x. Our next special factorization is the perfect square trinomial, which comes in two forms. Notice the difference between the two trinomials. The middle term has a plus sign on the left and a minus sign on the right. Those produce different factorizations, but both of those factorizations are perfect squares, hence perfect square trinomial. Let's look at the logic behind why these factorizations work so nicely. We'll start with the factored form. We'll represent it clearly as a product. We FOIL that product, and we notice in both cases the middle terms are like. So we put them together. Let's try to factor this trinomial. It seems to fit the form of a perfect square trinomial. 4x squared is a perfect square, and 9 is also a perfect square. So this should factor as a perfect square. No, not even close. What happened? Well, let's take a gander at that middle term. We know the first and last terms are perfect squares, but that middle term looks a little suspicious. If 4x squared is a squared, that means that 2x is a. And if 9 is b squared, that means b is 3. 2 times 2x times 3 does not equal 8x. So it actually doesn't fit the form. Let's fix our trinomial so it factors like it should. 4x squared is a perfect square, as we've mentioned, as is 9. Now let's check out that revised middle term. 2ab is what our middle term should be. 2 times the square root of our first perfect square times the square root of our second perfect square. That should equal the absolute value of the middle term. And in fact, it does. That's why we get a good factorization. 2x plus 3 quantity squared. That's a plus b quantity squared. Now, why do I have a plus sign here rather than a minus? Well, look at that coefficient of 12x, and that's all you need to know. If this is a plus, that's going to be a plus. If this were a minus, that would be a minus. Let's try to factor another trinomial. Before we do, let's make sure that middle term checks out. I see that 9x squared is a perfect square, as is y squared, of course. That middle term was suspicious in one example, but it's not suspicious here. I see that 2 times the square root of 9x squared times the square root of y does in fact equal the absolute value of my middle term. So this should factor. Take a moment and pause the video and try to factor this trinomial. Okay, I'll assume we're ready to continue. The correct answer is 3x minus y quantity squared. Notice that since I have a negative 6xy as my middle term, I'm going to have a minus sign in my factorization, as opposed to a plus. Now here are a few polynomials for you to try to factor on your own. Feel free to pause the video and give each of them a go. Unless, of course, they can't be factored in the integers. One quick hint. Try factoring out a monomial before proceeding to one of the techniques from this video. Alright, I'll assume we're ready to continue. The correct answer for number 1 is 3x plus 7 quantity squared. The answer to number 2 is 25 times 2x plus y times 2x minus y. A great first step would be to factor a 25 out of both terms. Number 3 is not factorable in the integers. That's because 2 times a times b, the square root of 16x squared, and the square root of 1, does not equal the absolute value of 4x. It's not a perfect square trinomial. And the answer to number 4 is 9 times quantity 4x minus 1 squared. Again, it's helpful to factor a 9 out of the trinomial before proceeding to factor a perfect square trinomial. Hope you enjoyed this video. If you're feeling what Mr. Penguin is feeling, check out my website in the description. And as always, be sure to click subscribe, hit the like button, and all that good stuff.